And thank you all for standing by. At this time, I would like to remind all parties that your lines are on a listen-only mode until the question and answer session of today's call. This call is being recorded. If you have any objections, you may disconnect at any time. If you would like to ask a question, please press *1 on your phone, and your line will be placed into a queue. One moment for the call to begin.
Hello and welcome to this update regarding our exploration science program here at NASA. I am Karen Fox with NASA's Office of Communications, and we're going to be providing an update today on the Viper mission. We have just shared a NASA media release and posted information on our website at nasa.gov, so be sure to look there for additional details. On the phone today, we have Nikki Fox, who is the head of NASA's Science Mission Directorate, and we also have Joel Kearns, the Deputy Associate Administrator for Exploration within the Science Mission Directorate. They're each going to start out giving some remarks, and then we will be answering questions from media on the line. You can get in the queue by dialing *1. We will start with Nikki. Over to you.
Thank you so much, Karen. Good afternoon, everybody, and thank you for joining us. As Karen noted, we've just shared our post online that we have some news that NASA intends to discontinue the Viper mission. Decisions, of course, like this are never easy, and we've not made this one in any way lightly. But in this case, the projected remaining expenses for Viper would have resulted in having to either cancel or disrupt many other missions in our commercial lunar payload service line. So therefore, we've made the decision to forego this particular mission, the Viper mission, in order to be able to sustain the entire program. I'll note that NASA has notified the Committees on Appropriations of the agency's intent to discontinue the Viper mission, but as always, we won't be executing that decision without the concurrence of our friends on the Committees on Appropriations. Now, Joel Kearns is going to be giving some more details, but I just really wanted to kind of start by putting some pretty important context on the table. So first and most important, this is in no way a reflection on the quality of the work from the mission team that are working to build this rover. They have worked diligently, including through the pandemic, to be able to build this rover to look for water on the moon. So this is a very tough decision, but it is a decision based on budgetary concerns in a very constrained budget environment. But it is certainly not because of any failure on the team's part to build this machine that certainly lived up to NASA standards. And I do want to take this opportunity to thank the entire mission team for their incredibly diligent work throughout the years. Now, Viper was designed to search Earth's moon for ice and other potential resources. And of course, that is in support of NASA's commitment to study the moon and to help unravel some of the great mysteries of our solar system. So we know how important this is, and we are still moving full steam ahead on this goal. We continue to explore the moon in many ways, certainly more ways than we have ever before. And we have copies of three of the Viper instruments that are already scheduled to fly on other missions. Additionally, NASA has the Polar Resources Ice Mining Experiment, or Prime 1. That payload is scheduled to land at the South Pole during the fourth quarter of 2024 in search of water ice. We're also looking forward to NASA's Lunar Trailblazer orbiter that is currently in development and sort of currently finishing up. And that is designed to determine the form, distribution, and abundance of water on the moon's surface. Additionally to that, future instruments as part of NASA's crewed missions, for example, the Lunar Terrain Vehicle, will allow for mobile observations of volatiles across the South Polar region, as well as providing access for our astronauts to explore the moon's permanently shadowed regions for dedicated sample return campaigns. So despite what's happening with Viper, we are committed to continue to study the moon and to look for water and ice in all of our future missions. I also just want to touch a little bit on the Commercial Lunar Payload Services, or our CLPS initiative. Viper was a payload as part of that initiative because we really believe wholeheartedly in the ability of using U.S. commercial industry to deliver payloads to the moon quickly and relatively inexpensively to create a lunar marketplace that expands across the moon, really not seen since the Apollo era. We have 6 CLPS launches currently planned, with more to be selected very soon. And this decision will not affect any existing CLPS task orders or NASA's other planned CLPS deliveries. Astrobotic, which was the CLPS provider responsible for Viper's launch, will continue its Griffin Mission 1 within its contract with NASA. And we're looking forward to that landing, now obviously without Viper, but it will still provide a flight demonstration of the Griffin lander and its engines. So again, I just want to come back to what I said at the beginning. This has been a really tough decision, which we make in an uncertain budget environment. But we do believe that this is a way for us to continue to support the entire CLPS portfolio and our dedication to studying the moon to support landing for the first humans, and to continue to do this groundbreaking science for the benefit of all. And so I'm delighted to now turn over to Joel Kearns.
Hey, thank you, Nikki. Let me first start off by repeating what Nikki said at the beginning. We really are grateful to and support the Viper project team and recognize the hard work they have put in on formulating this mission and getting this rover put together. Building a rover like this takes real innovation and dedication, and we know that we have the cream of the crop of staff working for us on missions like this. So given the current situation, I'm going to give some more information about what brought us to the point where we are and what our next steps are. Since 2021, the Viper project costs have gone over their original commitment and are now expected to exceed what we call the baseline development cost by more than 30%. Such a cost increase automatically triggers in NASA a cancellation termination review, which was held in June. The Viper rover was originally planned to launch in late 2023, but in 2022, NASA directed Astrobotic to add 3 pre-flight tests to the Griffin lander. NASA agreed to delay the launch to late 2024 to allow time to conduct these tests. Since that time, additional schedule and supply chain delays for Viper have pushed Viper's landing readiness date into 2025, the earliest time that they could actually have the correct lighting conditions to take their measurements on the moon would be September 2025. And independently, the CLPS launch aboard Astrobotic's Griffin lander has also been delayed to no earlier than September of 2025. Continuation of Viper would result in an increased cost that would threaten cancellation or disruption to other selected and future CLPS missions. So consequently, based on that cost increase, but also delays to the launch date and the risk of future cost growth, NASA made the decision to stand down on the Viper mission. We've also notified Congress, as Nikki pointed out, of the agency's intent. Moving forward, NASA plans to potentially deintegrate and reuse Viper's scientific instruments and components for future moon missions. As Nikki said, we're committed to studying the moon for science, including the presence of water ice, and reusing scientific instruments would be one way to do that. In that scenario, the project would conduct an orderly shutdown and close out through spring of 2025. However, prior to that assembly to gain the instruments, NASA will consider expressions of interest from U.S. industry and international partners by Thursday, August 1st, for use of this existing Viper rover system. This would need to be at no cost to the U.S. government, and we posted information as part of our press release at nasa.gov with information on how to express that interest. I want to end by adding my thanks again to the Viper team, as well as our CLPS colleagues at Astrobotic Technologies for all the work that has gone into this project so far. We really look forward to putting what they've learned to use as we go forward to explore the moon.
Thank you so much, Nikki and Joel, for your remarks. We are going to move on to questions now. The first question we have is from Bill Harwood with CBS News.
Wondering, Joel, can you put any update us on what the costs are to date? And when you say 30% over and all that, I mean, what are we referencing? If we could have some actual cost numbers, I'd appreciate it. And then the second thing, real quickly, is the objectives of the Viper mission. Do you still plan, how will you incorporate those objectives into other CLPS missions and or Artemis missions to get the science that you're not going to get now? Thanks.
Thank you, Bill. So to give you some context, when we formalized the Viper project, we told Congress that the budget for the project would be $433.5 million and that the landing would be the end of 2023. As I mentioned earlier, we had already made the decision to reschedule the landing for 2024 so that we could have Astrobotic do additional propulsion tests on the lander. When we made that decision, we updated the Viper work plan and we reset the budget to $505.4 million with a landing at the end of 2024. But our latest estimate that was done earlier this year showed that since we were no longer planning to land a Viper at the end of 2024, but instead would have to do it for the science window of 2025, that the cost for the Viper project would be projected to be $609.6 million. And that's why we said it's a growth of greater than 30% when you compare it to the original commitment we made to authorize the project. Now, Viper is one element of many different investigations that will go on in our lunar campaign, stretching out over many years. As Nikki pointed out, we have orbital remote sensing satellites, some like LRO in place today to search for volatiles remotely, some coming soon in the future like Lunar Trailblazer, which will launch at the end of this year. But we have a large number of different efforts on currently planned and future CLPS missions that will go to the South Pole of the Moon. In the beginning, they will search for volatiles in the sunlit regions because it's very difficult and to get into the permanently shadowed regions on the Moon. But after a while, we will have capabilities like the Lunar Terrain Vehicle that will allow us to send, when astronauts are not using it, have it be remotely operated to go into areas like permanently shadowed regions to take measurements. We will someday have the ability to have crews walk into small permanently shadowed regions to take samples and make measurements. And we're looking at the possibility for being able to send CLPS landers either into permanently shadowed regions or to have CLPS landers provide some type of mobility that would get the instruments in the permanently shadowed region. So we believe that over time we are going to be able to address the science objectives that we originally identified specifically for Viper.
Thank you so much, Joel. Moving on to our next question. Issam Ahmed with Agency France Presse, please.
Hi, thank you for taking the question. I was wondering if you already mentioned this, but what was how much was spent so far on Viper? And the second part of the question, I guess, is a bit bigger picture. Does it feel like the U.S. is starting to fall behind China in its lunar missions, given the sort of massive advances that China has been able to make on the far side of the moon, and in terms of bringing back regolith quite recently? Thank you.
Thank you. So for your answer to your question, in effect, how much have we spent so far on Viper? Through about June of this year, we have spent about $450 million of the totals that I mentioned earlier. Now, to answer your second question about comparing this to other efforts on the moon and in space, I'll point out that we have first off, we congratulate China National Space Agency for the seemingly very successful Chang'e 6 mission that returned to Earth in June. Where our program is very diverse, with a large number of scientist-proposed investigations that we compete, and we pick the ones of the highest scientific merit to answer these scientific questions that have been recommended to us by the National Academy of Sciences. And we're doing it in a way, particularly for the ones that go to the surface, where we're tapping U.S. industry and buying the transit to the surface of the moon as a service instead of building our own lander, because U.S. industry says they can do that for us. We do think that that's going to, in the long term, generate cost savings compared to doing it ourselves, and also as there are more and more opportunities to land and landings are carried out, higher reliability systems. We also have the advantage, the way we're doing it with U.S. industry, that we see many different technical approaches that the different companies are using in order to successfully land on the moon. And it's clear that they have different strengths. And by pursuing the method we're doing of having many landings as opposed to just a fewer number of landings over several years, we think that we're going to have a more robust science program and a more robust lunar landing capability in the United States.
Thank you.
Thank you. Moving on to our next question. It is from Will Robinson-Smith with Spaceflight Now.
Yes, hi. Thanks for taking your questions this afternoon. I suppose a question for Joel Kearns. In addition to the Griffin lander demonstrating its engines and its landing capability, are there any other additional science objectives that can be assigned to Griffin, given Viper's no longer flying with it? Is that still an option at this point? And if so, what could we see as an additional objective? Thanks.
So Astrobotic's Griffin mission 1, in addition to its big objective, which was landing Viper on the moon, is also flying commercial payloads that are not NASA payloads. So I would have to direct you to Astrobotic to answer questions about the other experiments and payloads that are already on Griffin mission 1. What I will say is that our plan for Griffin mission 1 with Astrobotic is that we will provide a mass simulator that is something that weighs the same that the Viper would, so that the lander can appropriately fly and land at the South Pole if it's transporting a large cargo element, which is what we would use in the future a lander like this for. However, Astrobotic will be able to go out and solicit business for other commercial payloads on top of the ones that they've already got, simply because of the fact that we will not be using all the resources now on this Griffin, like power, electricity, et cetera. But also, if they want to fly more commercial payloads, we could make our mass simulators smaller so that the total mass is the same, but they have other payloads. We have decided at NASA, given the scope and the schedule and the cost, that the fixed price cost that we've agreed with Astrobotic for this Griffin mission, that we will not substitute additional science instruments on Griffin, because we feel that if we did, it might lead to schedule delays and increased costs for the government. So our focus now on Griffin is to get the data out of the successful landing of how their propulsion system works, see their demonstration that they successfully landed a large lander at the South Pole. So we have that information for the future. And of course, we would like them to make the best use they can commercially for other payloads on their mission.
Thank you, Joel. Our next question is from Jeff Faust with Space News.
Good afternoon. Question for Joel. Were there specific issues with Viper that drove up the cost? You mentioned supply chain issues, but were there specific issues in the development itself that drove up the cost? Because you mentioned schedule delays, but it's clear that Griffin would not be ready to carry Viper until late 2025, is the way it was sounding. Thanks.
Well, first of all, I want to point out that the Viper team did a fantastic job on Viper. In some ways, they did a really heroic job working through COVID and then dealing with all the supply chain disruptions that came out of COVID. What happened after we rescheduled contractually with the Griffin landing to be delayed from 2023 to 2024 is after that happened, Viper was subjected to a large number of critical flight component delays from their suppliers. And the Viper team went out and attacked this really vigorously to try to get those components delivered on time or at least mitigate the delays that they were seeing. But in effect, the delays occurred over and over for several key components. And if you are familiar with the Viper system, Viper is it's a very dense rover system. Some people say it's the size of a golf cart, but I consider that it's the size of a small automobile. And Viper is built up from the inside out, and many of the components that were delayed were actually at the intersection of Viper. So as the components were delayed, it started forcing the Viper team to delay the assembly and delay the integration and the initial testing to the point where we felt by the very beginning part of this year that Viper might not be available for its turnover date to Griffin to allow a launch at the end of 2024. And simultaneously, as you know, we were getting information by the beginning of this year that Griffin would not be ready to fly at the end of 2024 and would likely fly in 2025. So we had both aspects contributing to it. But I want to point out that also the delays of the component deliveries that Viper was exposed to, it wasn't a big delay that happened all at once. It was individual component suppliers projecting a small delay and then another small delay and another small delay. So the Viper team did not have the opportunity, say, to look at a very long delay and then plan around that. They fought really hard to get the components delivered as soon as they could get them, but they were still relatively large delays that prevented them from moving into assembly and test.
All right, we are moving on to the next question, which is from Jim Siegel with Florida Media Now. Jim, are you there? If not, we will move on to Joey Roulette with Reuters, please.
Hi, thanks. I was just wondering why not put or attempt to put some kind of science payload in the place of Viper instead of doing the mass simulator? And how does NASA kind of assess the viability of its commercial intent with missions like these? And would it have changed things with this program if it could rewind time? Or what would it do differently in the past? Thanks.
To answer your first question, although we internally did consider the idea of substituting science instruments for Viper, the Griffin rover was designed by Astrobotic primarily to bring a rover like Viper down to the surface. If one were to say, instead, I want to put scientific instruments actually on the lander and use it as a fixed lander, you'd find that they didn't have, in their current design that they're building, the type of power supplies or communications or other services that science instruments would need in order to operate on that particular lander with them not roving, just sitting on that lander. I would say in response to your, we believe that if we were to ask Astrobotic to make changes like that, it would further delay their schedule. It would lead to more cost to the government. It would lead to a delay of the demonstration of a successful South Pole landing by the large Griffin lander, which we are very interested in seeing. I believe in answer to your second question, I would say we're always learning lessons from commercial lunar payload services. We've had our first 2 landing attempts early this year. We have 2 more landings coming up at the end of this year, and then, of course, more landings in 25 and 26. I would say the one thing that was different about the Viper mission that we decided to do in 2018, 2019 using CLIPS was that it's a very large and very sophisticated payload that required a very large, somewhat unique lander to bring it to the surface of the moon because of how large and massful the Viper system is. And I think that when we look back and think that we originally thought in the government that the first landings of the moon would take place in 2021 and 2022 by CLIPS, but in reality they're taking place in 2024. We and the companies have not yet accrued enough experience to probably understand how to smoothly deliver such a large and sophisticated payload as Viper to the lunar surface.
All right, our next question is from Nell Greenfield-Boyce with NPR.
Thank you for having this call. So can I just understand, how complete is the Viper rover at this moment? I mean, is it essentially finished at this time? And I'm a little confused because on the one hand, you said you guys were going to look for opportunities to reuse some of the instruments, which I assume would mean taking them off the rover. But then you also said you were going to open up for proposals to private or commercial entities that might want to use the rover if it was no cost to the government. So could you just expound a little bit more on this, like what the status is of the rover and like what are the ways bits of it might be reused or the way the whole rover might be reused in a non-NASA setting? Thank you.
Oh, thank you. So as of today, I really think as of June 4th of this year, the Viper rover itself, the flight rover, is completely assembled, but it's only now going through what's called system-level environmental testing to show that, for example, it could take the vibrations of launch or the sound levels of launch or, as say, thermal or the temperature conditions and the hard vacuum of space. So the rover is put together, but it's not gone through its complete test program yet to show that it functions and that it will function after being subjected to the launch and landing environment. Our plan, as I said earlier, is that prior to making use of high-value components like the scientific instruments or the drills or the batteries or the solar arrays that we have on this completed but not yet tested rover, prior to doing that, and as part of the media release that we've let out, we are asking anyone that has an expression of interest, say in U.S. industry or an international partner of the United States, to express that interest back to NASA if they have an interest in effect using the Viper system as it exists today, a completed flight system but not yet tested, and see if there are any expressions of interest that would come to NASA that would look like they are very valuable to NASA, and that might be more valuable than, in effect, deintegrating some of the components of the scientific instruments for Viper for use on future missions. Either way, whether we do get potential partners that come forward and can reach an agreement with the government to use the Viper system as it exists, or if we take off recently developed flight-certified components and repackage them for use in future CLIPS or other lunar missions, we will get value out of the Viper system, the way that it's put together, and certainly out of all the experience that the Viper team generated over the last 4 years of developing such a complex system to operate at the South Pole of the Moon in the cold and the dark.
Thank you.
Next question is from Ken Chang with the New York Times.
Hi, thank you. I was wondering how much will you have spent at the end of this? So you've already spent $450 million, and you're paying Astrobotic to fly to the moon anyway, and I assume at the same cost. How much is that? And so what's the total cost you will be spending, and how much are you actually saving by not having Viper on it?
Okay. So our NASA's contract with Astrobotic to deliver Viper and also a laser retroreflector to the moon on their Griffin mission is $323 million. And that contract is in process right now. As time goes on, as they complete milestones in it, we make progress payments to them to conduct the entire delivery for us. And right now, the Viper project is baselined at a cost of $505.4 million in order to be ready to launch at the end of 2024 to be taken to the South Pole of the moon. But as I said, we know that Viper has been delayed, so it would not be ready for that. And we know that Griffin has been delayed, and it would not be ready for an end of 2024 launch. So if by stopping going forward on Viper today, we're going to avoid a cost of about $84 million at a minimum, which is the cost to continue to finish the rover flight and ground systems, and then operate the mission, which now can't take place in 2024. And that would be the difference in cost. That's what we'd be avoiding.
Thank you, Joel. Our next question is from Stephen Clark with Ars Technica.
Hi, thank you for my question. My question is probably for Joel. Was the risk of landing Viper on the unproven Griffin lander, was that part of any of your decision calculus to get to this point to terminate the mission? Just don't want to risk the rover on an unproven landing system. And I just want to clarify the cost as well. The estimate of $609 million, if I recall, correct me if I'm wrong, for Viper, is that inclusive of the $323 million for the Astrobotic delivery contract, or is that should we add those two numbers together for the total cost of what Viper would have been? Thanks.
You would add those numbers together for the total investment by the government to do the Viper mission using the Griffin mission. What we took into account in our decision was the projection of the cost to proceed with Viper, but now for a fall 2025 launch and landing date, and then do its science operations for 100 days after that, plus the fact that the Griffin lander would not be ready until no earlier than September of 2025 to launch. I'll point out that developing and building a lunar lander is extremely challenging. Each of the CLIPS lander companies is working really, really hard, each with their own technical approach to have a successful lander. So we took into account the fact also that it could be at least possible that the Griffin lander availability to launch could be delayed past September 2025. The Griffin lander itself would have to be able to launch by November of 2025, or else it would miss, in effect, the Viper science operations window for that 100-day mission after it lands. Viper can only take its measurements during particular conditions at the South Pole when, in effect, there's a lot of sunlight available, which we call South Pole summer, and also a way to communicate directly by radio back to Earth. So we were taking into account the cost it would take to continue Viper, and also the risk that there would be that it would still be possible that either Viper or Griffin would not be ready at the launch date that was desired in 2025, and if it couldn't launch by, say, November of 2025, that might have forced us to recycle it one more roughly 9 to 12-month period into the future to get to the next time of good lighting conditions at the South Pole. This is a challenge for any long-duration mission that will go to the South Pole that doesn't use, say, nuclear power for heating and for power. You have to be very careful about how long you will be in darkness.
All right, our next question is from Marcia Smith with Space Policy Online.
Thank you very much for taking my question. It's probably for Nikki, but I'm just curious about the congressional reaction to this. And I think you said you wanted solicitations from industry or international people who might want to use any or all of Viper by August, but Congress certainly could not be making any appropriations decisions that soon. So I'm wondering why there's such a short timeline for them to respond to this idea. But basically, what kind of reaction did you get when you tell the appropriators? Did you get questions about if you've already spent 450 and you're only going to save 84, shouldn't you just press on with it? Could you tell us a bit about those discussions?
Yes, sure. We've sent our notification off, and as I noted, we are awaiting their decision, and of course, happy to have any discussions that they wish to have moving forward. So just really waiting for their response, and happy to discuss.
Thank you so much, Nikki. Moving on to our next question, it is from Jack Cure with Payload.
Hi, thanks. Just want to understand the flight readiness of the rover. I mean, it was going through environmental testing, and would it have been possible for this rover in the condition it is to land and be operational, or was there just too much of a risk involved? Is it an issue with experiments and instrument integration, or were you not confident that it would be able to function and operate on the lunar surface? Thanks.
So first I want to say that we have high confidence in the abilities of the team building the Viper rover. They built it with all the knowledge we have in-house at NASA. No one in the United States has built a lunar lander until we get to our CLIPS and our human lander system companies, going all the way back to Apollo and Surveyor. And we haven't built a rover for the moon, again, until this era, going all the way back to the lunar rover that the astronauts used, right, in the 1960s and 1970s. So we were very confident in the Viper team. This really gets down to cost in a very constrained budget environment in the United States, and also the cost, this extra cost that you would end up having, which is really based on going in completing, for example, from the part of the rover, all the system-level environmental testing, and that assumes that the testing does not uncover problems, which I will tell you, in general spacecraft development, system-level environmental testing does uncover problems that need to be corrected, which would take more time and money. And then, of course, we would be relying on the Griffin lander development to be able to provide us that landing service at that same target date in September of 2025. So from that point of view, from our point of view, those were both the cost and the schedule risks that we took into account in the decision. And we also wanted to avoid the cost of what happens if one or the other element isn't 100% ready to fly in that window at the end of 2025. As I said, if they didn't land by November of 2025, we would probably have to replan them to fly in 2026, and at least for the rover side, that would incur even more cost to the government for a later mission. So we wanted to avoid the risk of that cost also.
Thank you, Joel. Our next question is from Michael Greshko with Scientific American.
Hi, thank you all so much for doing this. One of the key pieces of Viper was the fact that it had mobility on the lunar surface, and that it was going to be prospecting for water ice across multiple locations. Could you be more specific, moving forward without Viper, how you all are going to achieve kind of breadth of sampling and more generally mobility on the lunar surface with rovers? Thank you.
Thank you. So what Viper was focused to do traverses through several different ice stability regions, that is, places where ice might be present on the surface or underneath the surface of the moon, and to be able to go in and out of these permanently shadowed regions, which you would think would have the highest probability for near-surface ice to occur. And that required a big rover with a lot of power and batteries, and also the ability to precisely plan those traverses in and out of different areas that are light or dark. Now, many of the smaller rovers that are flown by the United States and other nations don't have the ability today to go into those permanently shadowed regions and do measurements for extended period of time, in particular, say, to drill below the surface. But for example, the CLIPS mission that will take place at the end of this year it will carry a drill and a scientific instrument to take measurements underneath the surface in sunlit regions, but it will also have a rocket-propelled drone that will jump into permanently shadowed regions, take measurements, and then jump out of those regions again to report the data. In addition to that, there are a large number of international partners that are working on rovers that NASA will supply scientific instruments to that will be delivered to the South Pole by CLIPS that will attempt to go into permanently shadowed regions, take measurements, then come out and report the data. And as I mentioned earlier, the Lunar Terrain Vehicle Service, which is being developed primarily to transport astronauts away from the Artemis Human Landing System landing sites in the South Poles so that they can do science remote from the lander, it will have the capability to be teleoperated and driven from Earth into permanently shadowed regions up to a certain duration. We're going to evaluate at NASA what type of scientific instruments and other tools to put on that lunar terrain vehicle once the provider is selected, so that we can use the lunar terrain vehicle also to get into permanently shadowed regions, certainly by the end of the decade.
Mm-hmm. And just a quick follow-up, you mentioned these international partners. On what time scale would those rovers be online and in a position to deliver the kind of scientific data that Viper could have delivered, potentially a year and a half from now?
I would say it's probably in a time frame of 2027 to 2029, just based on announced plans. And I will point out that Viper would gather a lot of data at many different locations with large numbers of instruments, and that is something that the smaller rovers would not do. They would take one or two instruments, make measurements, and bring the data back. But when you go to these larger mobility systems like Lunar Terrain Vehicle or others that other international partners have proposed to NASA, those should have the capability to take large instruments and stay for appreciable periods of time to gather data in these permanently shadowed regions.
So the combination of the instrumentation diversity and the readiness and the mobility that Viper provided, that combination is not something that is going to be readily available for a few years. Is that right?
Yes, and we're going to be relying on providing mobility from our CLIPS service to bring scientific instruments around the surface of the moon, remote sensing. And I will tell you that if you look at the different investigations that will be done by many different CLIPS providers that will take our instruments to the moon, landing in sunlit areas, but also then having roving operations, there will be parts of the Viper science objectives that we think several years from now we will still be able to address.
All right, thank you so much for those questions. Our next reporter on the line is Ken Kramer with Space Up Close.
Hi, thank you. Can you hear me?
Yes.
Okay, great. Well, I have to say, I'm a scientist. I find this decision you've made really, really disappointing. I really don't understand it. For $84 million, if I understood you right, you're canceling this rover. What if Congress came back to you and gave you the money? Would you go ahead? Because, a one-year delay, that's common in NASA programs. I don't see that as being a super obstacle. I understand it costs more money, but you have a rover that's ready to go. And I want to know if you have considered other landers. Like, what about the Blue Origin, Blue Moon lander? Would that work at all? Thanks.
Nikki, do you wish to address any of that question, or let me address it?
Why don't you start? I'll come in at the end.
Okay. So first, I want to point out again something that Nikki Fox, I believe, said at the beginning, is we are in a highly constrained science budget environment at NASA. Science at NASA was $1 billion less in the current fiscal year than what was requested from the Congress, and that, of course, is the Congress's prerogative to provide funding for all the different federal agencies. But it's a very constrained environment, and we're getting indications that the environment will also be constrained in the next fiscal year coming up, fiscal year 25. Now, I want to point out again that the rover for Viper is assembled, but it is not through system-level environmental tests. Some of the ground systems that you need to operate the rover are not completed yet, although they're close to completion. And one of the concerns we had was the immediate cost that we would have to take out of something else in NASA science in order to get ready for the September 2025 landing. But another concern we had was the likelihood that the landing would actually not take place in September 2025. And if it took place later than November, it'd probably be taking place in 2026, which would probably require a similar amount of money to continue into 2026. So we were looking at avoiding costs and the risk of costs, as well as just the immediate plans cost that we were considering. I would also say that, I'll leave it from there and turn it over to Nikki, who's got a broader, more strategic view probably of NASA science than I would give you. Nikki?
Yeah, thanks, Joel. Great comments there. Obviously, our goal is to maintain a very balanced portfolio across the whole of the Science Mission Directorate. As I noted, if we did continue with Viper, it would affect the rest of the CLIPS programs. It would cause delays and probably cancellations of a number of CLIPS missions in order to be able to do that. I think Joel sort of did a nice job of outlining the uncertainty in the schedule, and of course there would be the cost of another lander that would be in there as well. No matter what lander we select, there will be cost to that landing. There's also things like different, and I know you know this, Ken, but the different launch loads, the different types of, you go on a different lander often drives changes to what you're trying to land, just because of the different environments, as launch environments and landing environments, in fact, that we haven't tested yet. So it's more about the cost risk and the threat against the rest of the NASA program should we move ahead. But of course, it is always Congress's prerogative. We are grateful for every penny. As Joel noted, we are about $1 billion less in the appropriated money in 24 compared to the President's budget request for 24, but we are grateful for every penny of that $7.3 billion, and we are doing wonderful science across the whole portfolio every second of every day.
Thank you so much, Nikki. We will go on to the next question. We have time for just a few more. The next question is from Anthony Colangelo with main engine cutoff.
Hey, thanks. When was this change communicated to the Astrobotic team, and what are their actual requirements now? You mentioned that you'll be supplying a mass simulator, but they could downsize that if they find payloads. Do they have control over the location of the landing? And is there anything else that they would be able to change about their mission? I guess the other question there was the additional testing that NASA was mandating because of the risk to the Viper rover. Do they still have to complete that as part of this?
Yeah, thank you. So speaking to Astrobotic about this, we pointed out, that we encourage them to find other commercial payloads since Viper won't be flying. We think that this demonstration of this large Griffin-sized lander is going to be very valuable to them and to the United States, that it be successfully demonstrated. It has many new components and a large scaled-up propulsion system that we don't see in other landers. I would also say that we are paying them to do those propulsion system additional tests, and they do intend to do them when they've got the lander integrated and the propulsion system ready. But those tests are yet to go. We think that they will learn a lot from that, and we do have confidence in them to go out and attempt this landing, or we wouldn't be continuing to work with them. They are a relied upon CLIPS vendor, and we think that the data that they will get from doing that landing will benefit them. It will also benefit the United States.
And just the first part of the question, when did they find out about this? Were they part of the review of the mission, or is this something that they're finding out pretty recently as well?
It's something they found out recently.
Thank you so much. Our next question is from Leonard David with Inside Outer Space.
Hi, can you hear me?
Yes.
Okay, great. Hey, for Joel, I just can you give us a little bit of a thoughts on the next CLIPS mission? The last time I looked on the schedule, Firefly was on track, I think, and I am too. How do you see that activity?
Yeah, both Firefly Aerospace and Intuitive Machines have publicly announced that they will make their next launch attempts during the fourth quarter of 2024. You would have to ask the companies, because again, these are their missions, what exactly their launch date is. But Firefly will be doing their first CLIPS delivery of 10 different scientific instruments from NASA to an area of the equatorial region called I believe, Mare Crisium. And these this will be the largest number of scientific instruments to date that we're taking down on a CLIPS landing. And of course, Intuitive Machines IM-2 mission will land at the south pole of the moon. It will land within about 15 kilometers of the true south pole of the moon into an area called Shackleton Connecting Ridge, at which point they will do the NASA paid-for operation, which is to drill below the surface and then make measurements of what elements that they find below the surface and see whether in the sunlit regions there might be water, ice in that region. But they will also conduct as part of what's called a tipping point technology demonstration, with our space technology mission directorate, a test using a commercial rover for a on-the-moon Wi-Fi system, as well as the rocket-propelled drone that I spoke about, that will hop away from the lander, take measurements, and eventually hop into a permanently shadowed region, and then hop back for the lander to give data. So we have those missions that the companies say are coming up at the end of the year. There's a third Intuitive Machines mission in 2025. There's a second Firefly Aerospace mission in 2025, and there's a Draper mission in 2026. And we are working now on selections for future CLIPS landings to carry NASA science to the moon.
All right, we have time for one more question, and then Nikki Fox is going to wrap up today. So our last question for the day is with Leo Enright with Irish TV.
Thanks very much. I'm just curious how all this works. If you're paying to land a half-ton inert mass on the moon, can you not just announce that any university or institution that comes up with a clever lander, like the Japanese smart lander had that little baseball-sized thing? I mean, could you not have what we in Ireland would call a come all ye to the party? Or are you in some way constrained that you can't offer payloads that might otherwise pay a commercial entity?
Thank you. First off, I would say we really encourage entities that want to fly their own payloads to contact the CLIPS companies and negotiate transport to the moon. The CLIPS companies would be happy to make that sale with people that would like to bring things to the surface of the moon. In our case, we have decided not to put different scientific instruments on the lander, even simple ones, as part of the process of taking Viper off that lander, because since the lander is so customized to bring this large Viper rover to the moon, if we were to put even relatively simple things on and substitute, it would require changes to the lander to provide power or temperature control or communications, which would not only make the lander more complex and probably lead to additional costs for the U.S. government, but might end up, again, delaying the lander readiness time. And even without Viper on the lander, we would like to have them conduct the landing so we can get the information of the successful landing and operation of their propulsion system as soon as they can do it reasonably. We want them to take the time to do it right, but we don't want to force a delay to their schedule. Remember that the government is paying them under a fixed price contract for the service of landing. So if we change our specifications and ask for new capabilities that they don't have, they could be free to quote a price, substantial price back to the U.S. government for this different service we'd be asking them for.
Thank you so much to everyone today for all your questions. If you have any follow-ups, do feel free to look at that release, follow up with us, and we will try to answer additional questions. You can follow along with all the upcoming missions that Joel has listed by going to nasa.gov/CLPS, that is CLPS. And to wrap us up, I'm going to pass to Nikki Fox for some last words.
Yeah, thanks, Karen. I want to really appreciate everybody calling in today and for your interest in the NASA Science Program. We're very proud of our portfolio of very balanced missions across all of our 5 divisions. Obviously, decisions like we've been discussing today are extremely difficult to make. We don't make them lightly. We put a lot of thought into the best way to move forward. We really do believe in our CLPS program. As Joel said, we're really enjoying working with the CLPS vendors to get as much science to the moon as we can. And so we have 2 upcoming launches at the end of the year, which we're all very excited about to do great science at the moon, including also our lunar trailblazer that will be orbiting around the moon. But I just wanted to, finish by thanking the Viper team for their commitment and dedication. We really do appreciate each and every one of them for the incredible job they've done to get us to where we are through some challenging times. But unfortunately, our budget uncertainty and our very challenging budget environment that we're in right now has been driving some very tough decisions across the portfolio. So just finish with, let's go the next CLPS launches. We're excited about those, and we look forward to taking your questions either on this or anything with NASA Science moving forward over the next few months. So thanks so much, Karen.
Thank you all, and we will sign off. Goodbye.